Okay, let's talk about lasers. All right, in your kit, you're gonna find a little laser, and it's something that you're gonna find in toys or cat toys, things like that. I mean, a laser pointer maybe. It's a very low-powered laser, but anyway, it's a lot of fun, and I'm gonna show you a little bit on how you can control that as well. So let's go ahead and head over to the bench, and let's talk about this laser itself. So in past projects, I've always provided lasers. The kids have always been fascinated by the lasers. Of course, the only thing they want to do is shine them around the room, which, usually means shining them at me standing at the front of the room. But now they're probably going to be shining them at you or your cat or dog or whatever. Anyway, they come in these little packages of 10, and they cost literally like $1 for 10 of them. So roughly 10 cents a piece. Now, the ones that you have are going to look slightly different than this. Here's how they actually come. They're very, very fragile. These leads break off very easily, and they don't have any way to connect them to anything on the end. They're just super cheap, but they're meant to be embedded into a particular project, and so they're just kind of the raw component. Now, what I do so that they'll be a little bit more resilient for use in our project is I do two things. One, I put a piece of heat shrink over the top of it, and I encapsulate the wiring so that nothing gets shorted out, but also it gives some nice strain relief. So now this isn't going to come apart and those leads aren't going to break. The other thing is I go through and I put these little crimps on the end. Now you might have seen these already if you were looking around on, for example, our motor. I've got these crimps as well. But anyway, these are just little crimps that I buy, and I can crimp them on, and then I put a little piece of heat shrink over that too, so that, and your color might be a little bit different. I can't remember what color I use. These ones are clear, so technically these are not going to be shorting out even if they touch each other because they've got that heat shrink on them. But these allow us to plug it directly into the breadboard. So anyway, that's a little bit on what I've done to prepare these lasers for you guys to use. So let's take a minute and talk about these lasers. These are known as diode red dot laser modules. And you can Google that, or you can look that up on Amazon or eBay if you want to buy a few hundred of them for a few bucks. The transmission power of these particular ones is 150 milliwatts. Now, actually, I think that's probably a little on the high side. I doubt these will actually use up that much current. Now, to put this into perspective, and if you, I know some of you asked me, do we need a resistor? And the short answer is no. You do not need a resistor when we're using these. And the reason is that they're already designed to work between, I think it's around 3.5 volts to the upper limit might be 8 or 9 volts, but we're going to be using them at 5 volts, and that's where they're designed to be used. You don't need a resistor because the Arduino can't put out enough current to have this thing draw too much and short out. Now, if you were to plug this directly into a 5-volt USB plug that's got a huge current capability of up to 2 watts, then yeah, you'll blow these out. But if you're using it with this Arduino and this breadboard, there's nothing to worry about. And the last thing I want to talk about is the wavelength. And this particular one is 650 nanometers, and it's red, obviously. If you've already plugged it in, you know what color it is. Oh, by the way, if you want to plug it in, you go right ahead. Just plug it in across the ground and 5 volts, and I'll show you that here in a minute. The reason I point this out is that this is in the visible spectrum of light. And I went ahead and grabbed a chart here. If you've never looked at this, I just thought it'd be useful to kind of overall take a look of the spectrum of waves. Now, some of you may not know what some of these things even mean, but down at the very low frequency, which is about 100 meters, is AM radio. So if you happen to know what a radio is, and you happen to also know what an AM radio is, you'll know most people don't use those anymore. And then up at around 1 meter is where we start to see FM. So if you're listening to a modern radio station, it's probably an FM radio station. And then if you happen to be getting your TV over the air using an antenna, that's also going to be in a little bit higher of a range, but that's also right around that, a little over 1 meter. I'm sorry, a little less than 1 meter. And then we get into radar. So if you're out speeding on the highway, most of them now are using lasers, but there may still be some radar. And then we get into the infrared, so your remote control that controls your TV, that's using an infrared signal. You can't see it because it's still not in the visible spectrum just yet. And that's something that's used on a lot of other devices as well. So for example, if you've got cameras can pick this up, but we can't see it. So if you've got an outdoor security camera, it may have some infrared light on it so that it can see in the dark. And then we get into this super narrow bandwidth here, which is the visible spectrum. And this is somewhere around over here, which I don't even know what the far left is, if it's 800 nanometers or what. And then it goes up to a little over 400. or a little less than 400 nanometers. This laser sits right in about this area, give or take. Again, I'm not sure how precise they are. And that's also why it shows up red. And then once we get out of this, we get into the ultraviolet and then X-rays and then gamma rays. And these are getting to be really small wavelengths, and they can be obviously dangerous. But X-rays are going to be things that are going to take X-rays of bodies, but they're also used for other communication processes. So anyway, that's just a quick overview of lasers and kind of where our laser fits in. So now that we know a little bit about our laser, let's plug our Arduino in and let's just give it power and see what it looks like. So I'm going to plug mine in, and you can plug yours in as well. You can plug it into your computer or even the little power bank. Either one doesn't matter. Now I'm just going to plug this directly over 5 volts and ground. Now it does matter which direction. Don't plug it in the wrong way. The red is going to be 5 volts, so I'm going to plug that into the 5 volts. And then the blue, and I believe everybody's is blue, you might have a black one, is going to be into the ground. Now you can see my thumb already lit up. This is I mean, it's not a powerful laser, but it's definitely a bright, bright laser. Now you can go ahead and shine that around and, avoid shining it in people's eyes or pets' eyes. But anyway, it's a lot of fun. It has a pretty decent range on it. It'll easily shoot across the room, so you can go ahead and play around with that. Now I thought just for measurement's sake, because I have one, I actually have a super powerful green laser. Let me go grab that. So this is actually a green laser. Somebody gave this to me, but I know they're not that expensive. They might be $20 or $30 off Amazon. Here's a little data sheet on it, and I did check. This one's 532 nanometers, so it's quite a bit smaller than the red laser in frequency wavelength. And this one's also 100 milliwatts, which is the output on it. This one runs at a slightly smaller battery, 3.7 volts, but it's all internal anyway. But anyway, this is a super powerful laser. You wouldn't want to get this in your eye. So I'm just going to shine it down on this piece of paper, and you can see it's got a huge, huge beam, and it will shoot literally down the street off of a house a block away, and you'll be able to see it. In fact, I'm not even looking at the piece of paper right now because the reflections off of the piece of paper will actually hurt your eyes. I mean, it's not going to damage them, but your eyes will be kind of like looking at the sun for a few seconds. Your eyes are going to be not burning, but you're going to have this white spectrum on it. This one even has a little key on it so you can lock it so kids can't play around with it if they accidentally find it. That's how powerful it is. So back to our laser. Let's go ahead and plug this in. Now, this is the same circuit I believe we were using last week. If not, I've got it up on the slide here in a second so you'll be able to follow it. But we're using the switch the same way we were. And what I'm going to do is I'm going to plug the switch in so that when you press the switch, the laser comes on and it just blinks like a specific pattern, and you can make whatever pattern that you want. Now I'm not going to bother with an extra jumper wire on this since we don't need a resistor. So I'm going to plug the 5 volts or the red one into pin 12. So let me see where pin 12 is. And then I'm going to plug the ground. Actually, I need to unplug my Arduino. There we go. So now I'm going to plug the ground into the ground over here. And now I've got that plugged into digital port number 12. Here's that wiring diagram that I did in case you need it. I've got it plugged into pin number 12 and then the other end into ground. So we're going to write this code here right now, but let's just head over and we'll do it together. Okay, I've got a blank PictoBlocks. Let's go ahead and get started. Let's head down to the Uno section. We're going to snag this when Uno starts up. And then just like before, we're going to grab the forever block because we're just going to put our code in to loop forever. So go ahead and get those two added, and then we're going to do something a little bit different than we haven't done before. All right, let's go ahead and grab our if block because we want to know when that switch is pressed. So let's grab the if block. We've used this guy before. We're going to throw that in there. Now, if this button is pressed, what I want to do is I want to loop around 10 times and blink my laser. So let's go ahead and put this one in, which is the repeat 10. So let's pop this underneath the if block. So I've got forever, if, and then repeat 10. Now we need to put a condition in here. So let's go down to the Arduino and let's grab the read digital pin. Here it is. So read status of digital pin 2, and we're actually using pin 2, so we don't need to change anything. We've been using digital pin 2, so we'll go ahead and just leave that as is. So now we want to turn that laser on, so let's just go ahead and grab the set digital pin, and we're going to do this 10 times, but we want to turn it on and turn it off. So let's grab 2 of these, and we're going to put them inside this block. We'll put a weight in here. Let's change this to 12 because we're actually using pin 12. And we'll change them both to 12, and we'll change this second one to low so that we turn it off. So go ahead and add yours. And the last thing we're going to do is we're going to put a couple weights in. So we're going to put a weight here, and then we're going to put a weight here after it's all done. So we're going to say Arduino starts, loop forever. If the button is pressed, loop 10 times, blinking it with 1 second apart. Now, I think 1 second might be too long, but let's also make it a little bit random. So let's change this to have it pick a random number. So if you go down to the operations, you'll see one of these guys right here is pick a random number between 1 and 10. So let's grab that. Now, anywhere where we've got a circle, we could use this value. So for example, we could even have it pick a random number here, or we can have it pick a random on-off time. So I'm going to put it right here and pick a random number. Now, we don't have a lot of values to pick from, so we can't really pick, this is number of seconds. So we can pick a relatively small number, but I don't know exactly how far we can do. So let's do 0.1 to 1. Let's see if that works. So now hopefully it'll pick a number between 1/10 of a second and 1 second. So it'll flash on, and then it'll go off for 1 second as it turns the LED on, and then it'll off, and then it'll loop, and it'll do that 10 times. So let's give that a try and see what happens. Okay, so that worked pretty well. If you want, you can mess around with these numbers. You can make them much larger or much smaller. The other thing you can do is you can set some of these to small values. Now this pick random is only going to pick a number between those 2 points, so we can't really do really small numbers within that. There's probably a way to do it with some of the math functions, but for now we'll just go ahead and use some regular numbers. Okay, so I got the code uploaded, so it's going to pick a random number between 1 and 3 seconds and run. So let's press the button and let's see. I don't have a big number here, otherwise we'll wait forever, but you can see that did 1 or 2, then 3, 1, 2. That looks like 2, 1, 2. That was 2 as well. 1, 2, 3. So now you can see it's picking a random number between them. You can go ahead and change those values to whatever you would like. I don't believe it's going to work if you do a small number like 0.5 to 0.10 or point to 1. I don't think it's going to work with the decimal points is what I'm trying to say. So anyway, you can mess around with that a little bit, and if you want, you can play around with some of the math functions within PictoBlocks as well.